I'm Matt Godbolt.
And I'm Ben Rady.
And this is Two's Complement, a programming podcast. Hey Ben.
Hey Matt.
I hear you've been thinking about databases.
A little bit. I have some ideas about databases.
So, when you mean database, you mean like SQL databases, like server databases, right?
Yeah,
as opposed to like the more colloquial...
MySQL, Oracle, if anyone still uses that. I don't know.
I'm pretty sure someone's still using
There's
Oracle.
There's got to be at least one or two people. Oracle seems like they have money, so there has to be someone somewhere
what about
that's using Oracle.
SQLite? Does that fit into your general pantheon of data buy? That is the plural database, I'm sure.
Yes, but in a more interesting way.
Oh, okay.
But yes, it does.
So what's your beef with databases?
I don't...
Because I'm assuming it's a beef, because otherwise you wouldn't have mentioned it.
I have a minor beef with databases in that I think that databases should be used to store relational data. If you don't have relational data, you should strongly consider not using a database. That is my beef with databases. Because I see many, many situations where people do not have relational data, and they're like, we have data. Where should I put this data? I'll put it in a database. And that creates a whole host of problems.
So to be clear here, you're talking about also relational databases, not like the Nosqul style.
Yes.
Which, I think that was a Lord of the Rings thing, wasn't it? The Nosqul?
Mm.
They were like the ring wraiths.
Yeah. The ring wraiths from Lord of the Rings, yeah.
I completely caught you off guard.
That is why...
No sequel, sorry, for the listeners who aren't playing along with the stupid pronunciation thing. No SQL databases, which are much more like just data dumps, with no relational component, or not with only complicated layering to get
document
there. You're talking
databases
about traditional
are
RDBMS things.
Yes.
And your observation is that some data that is non-relational ends up in a database because it's convenient, probably.
Yes.
Or it's just there.
It's familiar, I think, is a lot of what it comes down to, right?
Right.
People, they know how to configure them. They know how to use them. They know how to interact with them. They're comfortable with SQL. They have operational teams that can support them. There are lots of vendors that'll give you one. You've been using Postgres for 10 years and it's like super comfy. It's like a warm blanket, right?
Right. What's wrong with that?
Well, the problem is, it gets back to the old programmer adage of use the right tool for the right job, right? And just because a tool is familiar doesn't necessarily mean it's the right thing to do. Now, I'm going to have a slightly hard time blaming anyone for using, we had this phrase at Prevco, we said boring is awesome. And, using boring technologies, old technologies that work really well and are well-trodden and have all the bugs sort of wrung out of them already. I'm going to have a really hard time complaining that somebody is using one of those to solve a problem, because it's like, yeah, okay, you want to actually get this thing working and you don't want to be a technology fetishist and just use the newest, coolest NoSQL thing or whatever. Sure, fine, respect. But there are lots of times when you could get even more boring than a relational database and put it in, a file?
I was going to say, what could be more boring than a database?
Yes.
And you're telling me a file?
Yes.
So what is this boring axis that you're referring to? What is boring a proxy for in this particular instance? What are you getting from these things?
What are we getting from boring? Well, the first thing we're getting from boring is that there's a large community. The product, the tool that you're using has been used in a lot of different contexts. It has very nice documentation, has a large community around it that can help you use it. A lot of the bugs have been worked out of it. It's been used in production environments in a lot of different ways, and it's just a generally reliable tool. And
so that's like Postgres definitely ticks the box of boring in that respect, because it just works. Everyone understands that you can advertise for a job and say, hey, if you've got Postgres experience, someone can come in and you know roughly where you stand with that.
Yep.
But you're saying that even more, like before there was Postgres, before there was any database, there was a file.
Yeah, file systems. File systems are real boring. They're
even more boring than databases.
You put file systems on your resume, and people are going to go like, "What?" right? Like, it's super boring. But turns out, if you don't have relational data, files are a great way to store data. You can write them to the file system and read them, right?
So give me an example of the kind of data you're thinking about when you're very specifically saying, like, non-relational data. Give me an example, because I wanted to sort of get... Yeah.
Well, anything binary, first of all, right? Whenever I see people putting, like, JPEGs as binary blobs into a database, I'm thinking, like, okay, like, I get that you have a data storage device of some kind and you want to put the stuff in there. But, is that really the best place to put it? Now, again, if you have other relational data around it, you have relational data that needs to refer. Maybe
maybe it's your avatar in your forum system, and everything else is relational. You just don't have the ping stored in there. But it's not like you can do select ping _ decode of blah in your and like actually do something with it. The data. It's a. But I mean, that's why databases have blobs. After all, that is what these are meant for, right? But you're saying that, like, if that's all you're doing, maybe you need to think carefully.
Yeah. If primarily what you're doing is storing images, you really need a relational database to store your images. I think probably you don't. And there are also other reasons why, it's obviously important to think about the context and things are going to be used. Scalability is a big concern in a lot of different contexts.
Right.
You can get scalability through relational databases, but if you're using the relational database simply as a mechanism for scalability, what about an object store, right? You don't necessarily need to use files, or you can't use files because it's like, okay, well, this has to run on multiple computers. They can't all share the same file system without some NFS trickery that we don't want to do. Yes.
S3 type stuff.
Yes. Yeah. What about a file store? Again, you don't have relations in your data. Don't use a relational database. Use something simpler. So, there's stuff like that. So like for example, if you're building internal tools, right? Some internal website, something like that, the number of people that will ever use this tool in its entire lifetime is like 24, right?
Right.
Do you really need to run that on more than anything but like a single server or a virtual machine or something where, you can just write files and read files and back those files up and it'll be fine? I don't think that you do. And if you can do that, then you get a whole bunch of other stuff for free. We had talked on an earlier episode about the importance of manual testing, being able to run things locally and do what the users do exactly on your local development workstation, and be able to reproduce the steps that they take and troubleshoot things in the same way that they will. And I think that's extremely important. So important, in fact, that I would be reluctant to add any technology to a project that hindered me in that effort. One of those things can be a relational database. If you have to have a database loaded with all the data, with all the right schemas, loaded up on your machine, then you can't have a lot of automation around creating that.
Harder. It's harder to get.
It's harder.
Right.
You're right.
It's a barrier to doing it. It's not impossible. And like virtualization technology and other things have come along to make it a bit easier, but it's not straightforward compared to here's a file.
But the question is, will you?
Yeah, right.
Can you and will you are two different. Yes, I can make a Docker container for my database, and I can write all the scripts and tools to load all the things into it, and I can integrate that in with all my projects so that when I fire up the server or whatever it is, it also fires up the database and it tears it down properly so I'm not leaking Docker containers and my laptop crashed. Well, you had 35 instances of Postgres running. That's why it crashed. Right. All those things. You can solve all of those problems and take the time to solve all those problems. A lot of people don't. They just say, well, I'll just run the database myself, and then
or everyone points at the dev database, which you just assume runs somewhere.
Because they don't want to take
is someone else using dev right now because I'm running my tests against it. Oh, sorry, I'm bugging. We've all been there.
Yeah. So I think that's what people generally do because they don't want to take the time to automate it. But I think that there's an even better option there, which is why do we need a database for this thing, right?
So you mentioned files.
Mm-hmm.
That makes sense to me, right?
Mm-hmm.
I remember at Prevco, the sort of internal link shortener that was hacked together used exclusively an append-only text file to store, a space separated. Here's the short URL, here's the long URL, and it just loaded it into memory every time it started back up again. And there you are. That's a simple enough thing if it fits into memory. And that's a perfect, I think, example of what you're talking about. There's no relational in that aspect to this whatsoever. It can all live in memory, and so it was implemented as a JavaScript like map, literally from the short URL to the long URL, and it was, as I say, a text file. But what if your data is bigger than that, or needs to be indexed more than that? You get an awful lot for free with something like a SQL database. They're like, hey, I need to look up by this field or this other field. And now I can write the code to do that, but it's kind of easier if I just let the database manage that bit, and I can create 2 indices now, right?
I mean, if you're looking things up by various fields, that sort of smells a little bit like relational data to me, in which case I would say...
Not necessarily. Like for what take my URL shortener, for example. What if I wanted to say, okay, well, what are the short URLs that lead to this big URL? Like essentially an inverted index, right?
Right.
I can write the code just to have 2 maps, one that goes from short to long and one that goes from long to short. But I'm basically making a database, and if anyone needs anything more, like, hey, what about it has a user field in it as well, right? And that could be who created it, and I say, well, find all the ones created by me. Now that you were definitely straying into relational areas,
but I mean,
here.
the other aspect here is that if you're making a URL shortener for an internal application, then the lifetime of this application is going to have megabytes of data at the most, which means you can do just about anything that you want, right?
I'm sort of just making the point that like if you start down a road where you end up writing all of these things, and then one day you're like, oh no, it doesn't fit in memory. Well, this is annoying. How are we going to make it scale? How are we going to? And
if one day it's never going to fit in memory, okay, sure,
of course.
But there are certain categories of things where you can be like, the number of short URLs at this company.
Well, you say that. We actually did hit this problem, which is why I kind of bring this up. There was a API server could generate the short URLs, which meant that you could very quickly churn through and create thousands of them, which was fine until it then took days for the machine to restart because it had to read through terabytes of this text file. But it was, again, wasn't a big problem. And adding layers in your software could mean you could switch it out later on and put something else there.
Right.
But I'm just saying it's.
I mean, it's a hell of a lot easier to go from a set of flat files to a database than it is to go the other way.
Correct. But like the API that a database gives you is one that is sort of sort and search and find and reorder and limit and all these things, which you might not need in a relational data store, but you still want to be able to do those things, aggregate like stuff. And you end up writing that yourself. The file doesn't give you that. So the database is both the storage mechanism and the querying mechanism for that data. Whereas if it's a file, it's just a storage mechanism, and then it's up to you to kind of layer everything else, which is probably a feature, but I just want to sort of talk about that.
I mean, certainly if you find yourself building your own indexing system into flat files, it's probably time to move on to something else, right?
But maybe not a relational database is perhaps
maybe not a relational database. And one of the places where I definitely see people abusing relational databases is with messaging-based systems. Right?
Oh my!
With a message or an event-based system, people using the database as a terrible message queue, where they're writing things in and reading things back out and trying to time those things all properly.
Select star from this where ID is greater than or equal to the last ID I got from you.
Exactly.
And keep retrying. Oh no!
Did I get any new rows in this table? And that is a huge dysfunction. Right.
That sounds, that's definitely somebody running around with a hammer thinking that everything else is a nail at that point. You're like, well, I got my database. What else can I do with it?
Right. And the thing is that quite often systems evolve into sort of more event-based systems because people want things faster. They want them in real time. They want them to update automatically, right? Like I want my web page to update automatically. I want my report to update automatically. And so like they sort of evolve into these systems over time, and people don't stop and sort of reevaluate and be like, all right, well, while we have gigabytes of data and not terabytes or petabytes of data, maybe now should be the time where we take the leap to go from something that is relational to something that is more event-based.
Right.
And there are lots of tools for that. One of the things that I will say is that I personally think it is generally easier to create the sort of like in-memory / stub / fake implementations of most message systems than it is to reproduce all of SQL.
Right.
And you alluded earlier to SQLite, which is possibly the one exception to this, right? And it's a great tool and you should use it if you find yourselves in these situations. But generally, if you've got N consumers and M producers and you just want to tie them together, like you can do that in memory for a single node to test locally pretty easily, right? So you can have your real producer consumer that talks to, Kafka or RabbitMQ or ZeroMQ or, your message bus of choice, whatever. And you can have an alternate implementation of that is not talking to any of those services, just runs entirely in memory. And as soon as it receives a message, it sends it all to the producers because they're all in the same process. And that makes it really easy to run things locally and test locally in a pretty realistic way. Like, obviously, you're not going to be able to, like, tease out all the weird things about your messaging system by doing that. But, you can do most things. And so that sort of particular dysfunction, I think, is a bad one when people don't sort of take a beat to just say, like, maybe we should switch.
The thing you just said there about the SQL is an interesting one, though, because whenever I have used SQL, and usually it's with something like SQLite that I'm actually using a file somewhere, because for some of the reasons that you said, like I don't need a server or stuff. Mm-hmm. But I end up having to wrap all of my objects interactions with the database in a very high level abstract API so that I can test them, because there's no way in heck I'm going to test the SQL query itself. Or maybe I am, but there's only so much you can do and be sure that you've done the right thing there. So,
right.
And then and I guess there's the traditional solution to this is to have an ORM, which then maps your objects into a database, and you kind of assume the ORM just works, and then you test the objects or the ORM mapped objects and the interactions with those, and just assume. But yeah, having to sort of stub out something that looks like SQL doesn't sound very testable.
Yeah. Well, it's just you wind up with this sort of mock magic approach where it's like, okay, and maybe you do the thing where you make it till you fake it, right? So you like run it against the real database and you make sure that it really works, and then you stub out the parts that were interacting with the real database using the data that you got back.
The results that you got back.
Right.
Yeah,
right. Basically, it's like, write your test and don't mock anything out. Connect to the real database paste. And then copy paste and then edit, shrink it down, all that good stuff. You can do those techniques and that's fine. It's like a kind of a brittle test. Now, brittle's not the right word. I mean, it's a reliable test in that it will give you the same behavior every single time. You're not going to get any weird effects where it's like, I ran it and it failed and I ran it and it passed. It's like, no, you're getting the opposite of that with that approach, which is good. But if you ever change your mind about what you want that SQL to be, you have to go through the whole process again of basically taking the mocking out and then redoing it and putting it back in, right?
It's a bit more like the thing we discussed with Claire with the sort of like golden test, the acceptance testing, except there isn't an obvious place to put an automated system such as the test that she was talking about there, because you have to talk to the database and then you do this manual process of like getting rid of the wheat in from the chaff. And that's... Yeah. So we talked about SQLite, but although I sort of glossed over that a little bit, but SQLite is in an intermediate kind of form because it has some benefits. It certainly doesn't have the drawbacks of needing a central database server with all the Dockery thing or the dev instance or whatever. It can be it is just a local file on disk. So what are your feelings about that?
I think that's a really good intermediate thing. There was a project that I worked on. Oh God, when was that? I want to say it was like 10 years ago, but I don't even remember. But basically, we had made the conscious choice to stick to like very generic, ANSI SQL, basically, to say we are going to be able to work with any database, not just Postgres, not just something else, basically only for testing, right? So that we could run against SQLite, and you could bring the whole system up with SQLite and be very confident that when you moved over to Postgres or MySQL or whatever we were using for production, we were using Postgres in production. But
it would
just work, right? And obviously, there are cases where you can find different data vendors interpret things in different ways and run into problems. But for the most part, that was a pretty good solution. And I honestly, I feel like this was a while enough ago. I don't know if that's a realistic solution anymore, honestly. I feel like there might be people that are like, if you're going to use Postgres, there's no way you can write, standard SQL and have it actually get the value out of Postgres that you want. Like, okay, maybe that's
what
true.
I was going to say. The value there, like as soon as you start down the road of like stored procedures to update things, and which of course you typically would only do if you're starting to take the benefit of like maybe some of the more relational things in the database because you have to atomically update 3 tables or something like that. In which case you're kind of maybe we've moved out of the part that you were talking about where you're like misusing relational databases to store non-relational information. Well, that's like, no, that's a valid use of a database. If it's a database like RDMS stuff, fine, go knock yourself out. But is it just a file store of JPEGs or URL shortener? Even a URL shortener thing is more on the fence. But yeah, is this top of mind because of things that you're thinking about at the moment, or is this just something that came to you?
I mean, it sort of touches on something that I think we were going to maybe talk about it in a different podcast, but maybe this will be the blend of these two things, which is like the project makefile.
Mm-hmm.
You know what I mean? Where, like, I personally think that, who said this? This is probably not. I'm just going to attribute everything on this podcast that I can't remember who said it to Michael Feathers, and then I'll be like right 60% of the time. I've gotten a lot of wisdom in my career from Mr. Feathers. He's a wonderful person. But he said, code is a way you treat your coworkers.
Yes, I think that was him. Yes,
it probably is him. And one of those aspects, I think, is if you want to bring people onto a project, right? You want people to help you, fundamentally. You have to help them help you, right? You have to do things for them to make it easy for them to contribute. You can't just push it all on them and be like, well, if you're a real programmer, you would just read through all these things and figure out how it works or read my partially up-to-date documentation that I wrote 3 years ago or whatever it is.
Right.
You have to create an environment that is welcoming and friendly and easy to use. Otherwise, they're either not going to work on it or they're going to be forced to work on it and they're going to hate you, right? Or they're going to hate the code. They probably won't hate you, but they'll just...
Not you,
they'll be like, they will
grumble.
They might grumble about you a little bit, but they'll just hate the code, right? They'll hate the thing that they're doing, which is not good. It's just like not filling up the coffee machine or leaving your smelly lunch in the fridge. This is a bad thing that you can do to your coworkers and you should not do this. And so one of the aspects of this, I think, is you should be able to check out a repository and run a simple command and do all the things that we have talked about on these podcasts over many times. You should be able to run it locally and manually test it. You should be able to run the tests and verify that they pass. You should be able to deploy it. You should be able to build an artifact that is deployable. You should be able to do all of these things. And there's not that many. It's like maybe half a dozen, right? It's like run the system, run the tests, build a deployable artifact, deploy the artifact, right? If you can do those things, then you can do most things that software engineers need to do. And you should automate all of those things. How do you automate all of those things? That's another question. The way that I've been doing it in recent years is by using Make. Because Make is a tool that is good at resolving dependent tasks, sometimes in parallel. And it's ubiquitous, like basically any Linux environment that you're going to be in is going to have Make. And yeah, Make files aren't the easiest thing in the world to write, but they're actually not crazy hard to read. Like if you've already got one and you sort of understand how targets work, they're not crazy hard to read. And if you're working in a compiled language, you might want to use Make or CMake, but you might want to use Make to do some stuff anyway. Both. So you probably have them all there anyway. So it's not bad. Now, can you do this with shell scripts? Absolutely you can. I have. It works great. Can you do it with other tools? Sure. Yep. Again, applying boring is awesome. I would go for a more boring tool here because there are definitely some boring solutions. But that is a thing that I think is important. So to answer your question of why is this top of mind for me, it's because I've had a few projects recently that have had data that was marginally relational and certainly not very big that depended on a relational database that was like...
Got it. I figured there was a wound here.
Oh, and the instructions are in the README are like, install Postgres, load these schema, create these tables by loading the schema in, and then configure the Postgres URL to this, and then you can start the system up.
And you're like, no, make. I want to do make test. And if it needs Postgres, then fine. It may be even, it can bring, Docker, whatever, something, or any Podman data, but there should be no manual steps in this. That's the critical bit.
Exactly.
Anytime that I think, well, you and I agree on this very, very strongly, right? Every project that I've worked on, and I've had so much positive feedback from people that are saying like, I love it when it's your project because I just do git clone and then I type make and the compiler itself even gets installed on my computer and just works. I'm like, yes, that's how it should be. If I need a magical version of GCC because I need this particular flag, then I will arrange for that to be on your computer as a result of typing make, as opposed to here's a list of sudo apt-get install crap that you have to do first. Like that's not that should not ever be allowed. And yeah, I mean, there's a variety of open source projects that I've worked on that have a similar thing. And I think it's a big bit. And in fact, actually, someone raised a bug recently because it's one of the things that stopped working. But mostly, I can point people at, say, Compiler Explorer and say, yeah, you know how you get it running locally? Make. And it'll churn away for a bit. And then you go to port 10240, and then you've got your own local install of it. And it's like, people are like, oh, I was expecting there to be more. I'm like, no, it's just that because that's all you need. Again, it's broken right now, apparently. But yeah.
Working on it.
I think it's a valuable and important thing. It just and as an API, make you can go far worse than make, as you say. I mean, npm sort of does it for the JavaScript community at some point, and there's mavens and things and whatever. But make can run those. I usually have a make file at the top of my project that maybe even runs CMake that then runs Ninja for all but you don't have to know that if you're just saying no, make the project. I don't care. It's like, well, there's layers and layers of things going on. You don't need to know about it. Hey, Conan's being installed in a Python virtual env in your machine, and we're installing all the dependencies through Conan, right? But again, you don't need to know that. It just works for you, and it's all done through the magic of make.
Yep. And that serves two really important purposes, actually. One is that it is this sort of like, code is a way you treat your coworkers thing. But the other thing is that it is an absolutely correct form of documentation. Right? Like, how do you configure and build and deploy the system? Well, it's all here. I'm 100% sure it's correct because we use it every day, all day.
It's how my CI runs. It's how my deploys run.
Exactly.
It's how I run locally. Yeah.
Right. So not only can you read that to figure out how it all works, but you can confidently change it and know like, oh, if I make this change here, everyone's going to do it like this with this version of the code. There's no like separate, like, oh, well, there's the build, but then there's the code, and you have to keep them in sync. And if you roll back one, you got to roll back the other. Yeah. It's all together. It's all in one place, and it all works. And so there's huge value, sort of documentation and coordination value in automating those things. And this is, I mean, to me, this is sort of one of those things you just have to choose to do, right? Like we've kind of talked before about like, we're wizards. We can do anything. What you choose to do in the sea of all possible things is going to determine a lot about what your working environment is like and what you're able to do and what you're not able to do. I don't think any of our listening to this podcast right now.
I'm reliably informed that we have at least two, actually. Now, I was talking to somebody.
I would say.
Other than our respective spouses who are.
Right. So both of our listeners would agree, I think, that any of these things that we've talked about on this podcast are possible to do, right? It's just a question of should you do them? And I think that you kind of just have to start with the decision of like, yes, I'm going to automate this stuff entirely so that you can just type make. And yes, that might lead me down some strange paths where I'm, building tools to make sure that it is possible to do this. But if you make the decision to do it, then everything sort of will follow on from that if you're committed to it.
Just like we said earlier as well, as if you can start from the beginning in that way, it's easier than retrofitting it later. So if you're like, well, it's just always been the case. You type make and it gets everything. And we started with just hello world. And, we've got the compiler and we got the thing building. And then we added a dependency on a third-party library. Okay, we're going to make sure that comes down as part of the make file. Yep. And you sort of incrementally put it on rather than having it trying to sort of retrofit it. Yeah, it's easier to do those kinds of things. But again, I think you're right. It's an effort of will on your own part that you have to make that decision. This is going to be worth it. I'm going to take a hit early on And I mean, once you've done it a few times, it's not even a hit; it's just a way of life, right? So sort of the Zen, the Tao of a new project is you go, new directory. The very first thing I do is VI makefile, and I'll paste in. Worth saying, there's a really nice little pattern that we've picked up along the way, and both of them. Well, I've picked up from you, but I think you picked up from Jake McCreary, who picked up from someone else, of having like a help target that sort of greps itself out of the makefile, and thus with a bit of like awk and said and magical things, kind of makes an auto help page for your makefile. And so you can just, maybe your default target is that as well. So if you type make, it just says, hey, these are the things you can do, and you're like, that's great. But yeah, so that's what I'll paste that snippet into my makefile, and then I'll like just have a make echo target that just says hello world, and then start from there.
Yeah, that help file thing I think is nice. Like, just sort of gives you that sort of half dozen, here are the things you can do as a developer, and you sort of gets people started. The other thing about this is not only is this something that, if you started early, so you get that momentum going, it's easier. If you started early, there's actually lots of situations where you can, tap into the power of laziness in order to get people to do the right thing, which is, and a great example of this, I think, is continuous deployment. So if on day one, you've, follow my advice and say the first thing you do is deploy, right? So deploy your hello world that does basically nothing, and have it automatically deploy whenever you push to the main branch, then it will be difficult to not have production in sync with the main branch, because it's going to do that automatically whenever you deploy.
Yep.
And people will just orient their behaviors around that from the start. They'll be like, well, if we push to the main branch, it's going to deploy, so how do we make sure that doesn't break? Well, I know, I'll write a test, or I know, I'll do this other thing, or whatever, right? You got smart people, they'll figure it out. But if you start with that philosophy, it actually becomes the easy thing to do it right, as opposed to this extra step that you have to take.
Yeah.
But you have to start there, or you have to very quickly get there. Because if you go in later, it's like, well, we're gonna deploy to production every time you push to the main branch. You'll get 100 very valid reasons why that's a bad idea, right? And you should not do that.
And that's actually an interesting. You said you reminded me of a couple of issues I've seen in the last couple of weeks, which have both come down to projects not auto pushing on their latest version, and then later on somebody accidentally or as a side effect pushing a newer version of the project and breaking other things because it was like a relatively significant number of changes that got rolled out to a system, and you're like, no, if it's pushed every time you push, then we'd find out a lot earlier, and it would be causally linked with the thing that you had just done, as opposed to, but I just did this thing, how on earth can that affect this other thing? Oh, I picked up 2 weeks worth of changes in one go.
It's shocking how much, and I mean, if you talk to anybody that was into like lean systems and the lean stuff, like 10 years ago or whatever, they'll tell you this, obviously. But it's like it's shocking how much queuing theory there is in software development, management, and process and stuff. Right?
Oh.
Like if you understand queuing theory really well, you can start to see those things in how developers push out changes, right? And the whole Toyota production system and all that sort of fed into all this stuff. This is what the cool kids were talking about 10 years ago, really.
I'm not one of those.
The post agile people. Some of the agile refugees that were like, why are we all talking about stand-ups and cards and things? I just want to build stuff. But yeah, like queuing up changes. Like a perfect example of this is exactly what you're talking about, is the longer you queue up changes, the more cost there is to actually deploying those changes. And that happens in multiple dimensions. One is that you've lost context, right?
Mm-hmm.
Like the people who made the changes just have slept since then, and they just don't have the sort of top of mind knowledge that they would have had if there's like, all right, I just built this thing and now I'm going to deploy this thing. Hey, it broke. That's probably the thing that I just changed. I know exactly what's going on, and it's all the cache is all still warm, right? Like it's all up there. The other thing is that you can unfortunately sometimes defer those bugs for your coworkers, which not only have they slept since then, they are not you, which means they don't know anything about this change that's going out
to me. Yeah.
Exactly. So that can increase the cost. And the other thing is that you get errors on top of errors, right? So somebody checks in a change that breaks something. Somebody goes and makes another change, and they look at your code and they go, okay, well, apparently that's how it works now. I'll do that. And they're doing something wrong. And then they make two of those things that are wrong. And that just sort of compounds on top of each other until the thing finally hits the real world. And then that whole chain of things breaks because we were building wrong on top of wrong this whole time and you never knew it. So those are just some sort of basic ways, but it's like this general problem of if you're queuing up changes to your system, you're taking on a lot of risk, and you got to be really careful that risk is actually worth it. Sometimes it is. Sometimes you can't just do things where it's like, yeah, literally every change just goes right to prod. You know, there are situations where that can't happen. Lots of situations where that can't happen. Right. But understanding that your goal should always be to shrink it, right? And to also just like recognize, like, if you can't do this, well, here are some of the problems that you're going to encounter. You're going to encounter the problem like you saw today. Okay, how do we deal with that problem when it happens? One of the things that I have advocated for a long time is that git revert is not a personal insult. Reverting commits is something that you should take advantage of, right? Mm-hmm. Like, you will have a much more complicated operational process if you have this mentality of everything that everyone has ever committed to this repository must be either fixed or remain pristine or never get rolled back. Like, your life will be made so much easier if you just sort of have a meeting where we all come together and be like, all right, everyone in this room are all going to agree, if I revert your commit, it's because I love you. And I want you to be able to go on vacation and not have to worry that the code that you've committed to the repository is perfect and unassailable in all ways. You can leave the building and go home to your family and loved ones. And if I see that you've made a mistake, as we all do, I'm just going to revert it. And I'm going to tell you so that when you come in the next day, be like, yep, Ben reverted my commit. Thank you for reverting my commit. That means I can fix this now at my own leisure and not have to be woken up at 2:00 in the morning by pages or interrupted by dinner saying, hey, Ben, you committed a bunch of bad code and then you left the building and now we need you to fix it right now. It's like, well, can't you just...
I love this.
Can't you just revert it?
I think this is a brilliant analogy, yeah. Because there is... You're right. I mean, isn't it a funny social issue that, yeah, I do feel guilty reverting someone else's change. It's like, you know... somehow a bad reflection on them when it's like, no, it is a pragmatic thing that I'm doing to buy us back the stability that we had before, and unless their change was required for operational reasons, then often, as you say, it's like, well, okay, you can come back in tomorrow and you can revert the revert and then you can fix whatever issue it was and then you can, no harm done. And I'd like to think that if someone reverted one of my changes, I wouldn't feel put upon, but you know, it's I do like the, if I revert your changes because I love you and I want you to have a lovely evening without me hassling you, or a vacation or whatever. Yeah. Yes, whatever it is. I want you to be happy. I want you to be uninterrupted in your life, and I'm just going to revert your change and then we'll talk about it tomorrow, right? Or whatever, right? After lunch, whatever it might be. And it's one of these things of like, I feel like if you can adapt some of these things. We've talked before on this podcast about, like, you know, the reason that I got so interested in engineering practices, agile engineering practices in particular, is because I sort of realized it's like, if there's certain things that you do and you do them well, there's a whole host of other things that you don't need to do, right? And I feel like this is an example of that, where it's like, if you get comfortable with this as a team, as an organization, where it's like, yeah, when we commit, it goes right to master. It goes to the main branch, gets deployed to production. That's just how everything works. If we run into problems, we revert the commit, and then we've got a reverted commit, and then that gets deployed, and now the problem is fixed, right? If you do that, you don't have the queuing problems. Mm-hmm. You don't really have to worry that much about versioning and, like, keeping old versions. Like, you have sort of a nice thing of, like, you know, depending on the particulars of your project, not every project is going to be able to do this, but you can get into situations where it's like, you know, unless you find yourself very often needing to roll back, and your deployment system, however it is, doesn't let you just roll back to a SHA, which some do, right? Like, if you, depending on how you set it up, you can say, okay, well, everything we've ever deployed is just, you know, marked by the SHA, and if you want to roll back to a particular commit, you can roll back, you can rerun that SHA. But there's, like, a whole bunch of versioning things that you probably also don't have to
worry that much about.
Mm-hmm.
Like your solutions to those can be significantly simpler because, you're just reverting commits instead of, we need to roll back to version 1.27. And then where's version 1.27? I don't know. I stored it in an Artifactory or whatever.
Right.
We got to fetch it from Artifactory. There's just a bunch of stuff you don't have to build. So I think, and not every project is going to be able to do this. This is not a universal solution. But I think the main thing is just sort of thinking in these terms and trying to simplify things in these ways. You'd be surprised at what clever solutions you can come up with if you just embrace the philosophy of it. Right? Start with the philosophy and be like, how do we get as close to this as we can, and work backward from that.
So how do we get to that from databases? I feel like somewhere along the line, I know there is a link, but you kind of switched gears. You're like, and another thing. Make files.
I did.
But that's a great thing. But yeah,
yes.
So my understanding is that we got there from if you don't have to fire up a giant database or run against a big database, then that enables you to have the kind of self-contained hermetic project where you just clone the project and type make, and you can run all the tests, you can do all the deployment, you can do everything within that world without having some exogenous dependency, an exogenous unnecessary dependency on a database.
Exactly.
Just trying to make sure that we've got the trail.
Yeah, tie all these ranty pieces together. That's a good idea. Yeah, no, that's exactly right. It's everyone sort of agrees that simpler is better. And all we disagree on is what does it mean to be simpler? Some people would say why are you writing your own code to scan a file, to query things that you could just throw into a relational database. Isn't it simpler to just write a little bit of query instead of to write 100 lines of code? And my argument, a lot of the time, and again, this is very context sensitive, but a lot of the time is, no, I'd rather write 100 lines of code than have a database. Because if I have to maintain a database, then I can't do all these other things.
And the
other things are more valuable to me. Yes. Exactly.
Got it.
The other things are more valuable to me than saving myself 100 lines of code, right? I'll just write the 100 lines of code. It'll be fine. And then that means that when you clone my repository and make run, the system comes up and you can use it just as a user would with no special stuff to have to make it work. Yeah. And when I deploy it, I know exactly how it's going to work because I don't have to coordinate the deployment of the software with the deployment of a database or write database migrations that go from one thing to the other thing or any of that because I have my 100 lines of code to replace all of that.
Yeah. Cool. Well, I think that is databases fully covered. We need to come up with a better ending than that. Maybe we could stop a bit earlier than this and I'll just do some magic editing because that seemed like a natural end point. Or maybe we just put this into it and then everyone can see how rubbish we are at finishing things.
How bad are we at endings? We are this bad at endings.
You've been listening to Two's Complement, a programming podcast by Ben Rady and Matt Godbolt. Find the show transcript and notes at twoscomplement.org. Contact us on Twitter at 2CP, that's at TWOSCP. Theme music by Inverse Phase, inversephase.com.